EE World, I'm Martin Rowe. We are at the International Microwave Symposium in Washington, D.C., and we're in the Samtec booth. And what we've got here are a lot of RF cables. And Jim Alexander is going to explain why we have so many RF cables. This is Samtec showing some of their cables, some of their waveguides, things like that. And Jim Alexander here is going to explain this demo and how it works.
Certainly.
So Jim, go ahead.
Yeah, I'll certainly try. So yeah, today we're at the IMS show in DC. Samtec always does lots of different demos when we come to these shows. And today we're just trying to show a bunch of different use cases for some of the connector technology that Samtec uses and makes. So what we have here is basically just some traffic, some 24 gigabits of traffic running through transmit and receive up to 73 gigahertz through a flexible waveguide. This product here, we also have our glass core technology on both the transmit and receive radios. And then our new NitroWave cable, this orange cable that you see in front of you, is all basically our new cable line that we've come out with this year. So this is really what we're trying to showcase. Also, analog over array. A lot of people wouldn't normally run analog signals through an array type connector, but in between both of these boards, we actually use our C-Ray connectors to run analog signaling through them. So it's the demonstration just showing some of the things you can do with a lot of the different technology and products that Samtec makes.
So you said you're running this at both 24 gigabit per second, all right. And
yeah, constellation, basically a 16 by 16 constellation.
Yep.
With fairly discrete results, running E-band basically in 70 some odd gigahertz with a lot more cable than you'd necessarily need, but just really to demonstrate all the different products.
So this is the transmitter over here?
Transmit side is over here.
Okay.
So this is where our signals are coming in. This is our transmit radio here, where we're up converting everything, the circuitry, through the traditional waveguide type filtering, and then using our flexible waveguides in and out of an attenuator, programmable attenuator. The receive side, radio, reverse of the transmit, we're receiving the signal, down converting it and running it back through another C-Ray with analog signaling, and then back into the Keysight oscilloscope to show the results.
Now you said something about in these radios about some sort of glass technology.
Glass core, yeah.
Glass core, what do you mean by that?
So instead of a traditional, substrate for the circuit board, Samtec makes, and we have it on the video up here too, we make a glass type of material, which actually is a great use case for a lot of things where the glass itself has a coefficient of thermal expansion that's very close to silicon. So there's benefits from the CTE and how it'll expand over temp. But also, if you run any kind of lasers and things like that, you can run those lasers right directly through the substrate rather than a circuit board.
So the glass substrate is in here?
Inside the box.
Inside the box, right there.
Keeping some things secret, but
using
that glass core for the circuit board.
Okay, very good. Thank you, Jim.
You bet.